Let's now look at a related rates problem that involves the tip of a shadow moving. We are told that a street light is mounted at the top of a 15-foot tall pole. I put a diagram down here so that you can visualize what this looks like. We're told that a person 6 feet tall walks away from the pole along a straight path at a speed of 4 feet per second. We want to find how fast is the tip of the person's shadow moving when the person is 30 feet from the pole. What we're going to do first is look at our diagram and put some variables in there, and then we'll write down what we're given, what we need to find, and then the equation that relates those two. We're told that the street light is on top of a 15-foot pole, so we'll mark this length as 15. And then we have a person that is 6 feet tall, so we'll label this as 6, and they are walking away from the pole. So let's just make an arrow like this so we can see the direction that they're walking. And they walk away from the pole at a speed of 4 feet per second. So that means we need to set a distance here equal to x, because dx dt will be the speed that the person is walking. We want to then find how fast is the tip of the person's shadow moving. This right here is the tip of the shadow, and we want to see how fast that's moving, so we need to assign a distance to this, and I'm just going to label that L. So let's say here that x is the distance from the person to the pole, and then L is our distance from the shadow, or the tip of the shadow, to the pole. Now let's go ahead and let's put down what we are given. We are told that the person walks away from the pole at a speed of 4 feet per second. So we can now say that dx dt is equal to 4 feet per second. And we want to find how fast the tip of the person's shadow is moving. So that is going to be dl dt. And we want to find that when the person is 30 feet from the pole. So that is when x is 30 feet. Now what we need to do is we need to find an equation that relates x to L. We are going to use what's called similar triangles to get this relationship. I'm going to go ahead and copy down our big triangle. And let's go ahead and let's label this. We have this side is 15, and this distance is L. And now we're going to have a smaller triangle, and that's going to be the height of the person, and then this length right here. We're told that the person is 6 feet, so we can label that as 6. And then now we have to find this distance right here. So let's go back over here to our picture, and I want to highlight this distance right here. That distance is this distance, and that is going to be L minus x. So let's come down here and let's write down the equation for our similar triangles. We have the ratio of 15 is to L as 6 is to L minus x. Now what we're going to do is cross multiply. So we have 15 times L minus x is equal to 6L. So that is 15L minus 15x is equal to 6L. So if we keep the L's on the left, we're going to have 15 minus 6, so that is 9L, and we get a 15x on the right. And we want to find dl dt, so let's solve for L. So this gives us that L is 15 over 9x. And let's see, we can divide 3 into both of those, so we get 5 over 3x. Similar triangles are hard, but once you have it, the equation is actually pretty simple. So we end up with the equation L is equal to 5 over 3 times x. Let's go back up here and see what we want to find. We want to find dl dt. So we are going to take the derivative with respect to time. So we have dl dt is equal to 5 over 3 times dx dt. And we want to find dl dt. Looks like we have to go back up again when x is 30. So x is 30 feet. So this is 5 over 3. Going back up once more, dx dt is 4 feet per second. So this gives us an answer of 20 over 3 feet per second. So we can now say that the tip of the person's shadow is moving at a rate of 20 divided by 3 feet per second. Before we finish, I just want to point out one thing which I think is kind of unique to this problem. Notice that we did not use x is equal to 30 feet. What that means is the rate of change of the tip of the person's shadow doesn't depend on how far the person is from the pole. That rate stays the same no matter where the person is located.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.